Welcome back to our talk on logarithms. We've gotten some progress in there. We've got the basics of logarithms. We've talked about some of the simpler logarithms and some of the simpler applications of it. And in this next series, we will continue that discussion and we'll start to use them as problem-solving tools. So we're going to use them as a problem-solving tool. So one question that's still left unanswered from the previous series is this. We talked about Bobbert, and we never answered his question. He still has $20,000 in a retirement account. It's still growing at, I think it was 12% on the year. And we got to this equation here, and we just kind of left it hanging. What is T? How long does he have to work before he can retire? And actually, I boiled it down even more and still left it unanswered. What's the solution to just the equation 12 to the x power equals 10? Had it been x to the 12th, I would have taken a 12th root, but 12 to the x, how do we deal with that? And the answer is going to be using logarithms. Taking a logarithm can undo an exponential. So I want you to look at these real quick, and let's see if we cannot use the basic properties of logarithms to build towards a problem-solving tool. For instance, this first logarithm here, the log of 10 to the 5th power. Now remember, I don't have a base spelled out here, so we interpret that to be base 10. And so this is asking 10 raised to what power is equal to 10 to the 5th power? And you say, well, duh, Mr. Terrell, it's 5. And you're absolutely right. Right? The natural logarithm, e raised to what power gives me e to the 7th? Well, I guess it's 7. And now maybe you're starting to see where this is going, because if I took the log base 12 of 12 to the x power, I get just x, because 12 to the power of x is 12 to the x. And that is exactly what we're going to do here. If we're trying to solve an exponential equation, we're probably going to use logarithms. If we're wanting to solve 12 to the power of x equals 10, one thing we can do is take the logarithm of both sides. So instead of adding a number to both sides, instead of subtracting to both sides, or multiplying, or dividing, or squaring, or square rooting, another tool at our disposal, algebraically, is taking the logarithm of both sides. So I take the log base 12 of both sides, and I got log base 12 of the x. That's just x, and that's equal to log base 12 of 10, which, if you remember the change of base formula, and even if you don't, you can look it up, that comes out to be about 0.927. Well and good. And in fact, that's how it's going to be when it comes to solving exponential equations. First, you solve for just the exponential part, and then you'll take the appropriate logarithm. So you'll see here, I've got 10 to the power of x equaling 36. I'm going to solve that for my x value by taking the logarithm of both sides, specifically the logarithm base 10. Let's see here. Let me pull up my calculator real quick. And I'm going to do the log base 10 of 36. So for this particular calculator, I type 36, press logarithm. That's about 1.556. Obviously, it goes on forever and ever. Next up, I've got e to the x. So I'm going to do the natural log of both sides. So I'm looking at x to be the natural logarithm of 15, about 2.708, and stuff. Next one, though, I don't actually need a calculator for. I do the log base 5 of both sides, and I ask myself, well, 5 raised to what power gives me 1? And you'll say, well, 5 to the 0 power. So this right-hand side, when I take the log base 5, just comes out to be 0. Subtract 1 to both sides, I've got what my x value is. And I say all that not because it's fun, though it is, but we can finally now answer, what about Bobbert? So first, we're going to solve for the exponential part. So I'm going to divide both sides by 20,000. And then, this is where I'm going to start the next video, we will take that logarithm. See you then.